I'll now hand over to Professor.
So thanks, Emma. Ooh. So I've gone with the lapel mic option. So hopefully it's still working for the online folks, and clearly it's working here in the room, right? Okay, so thanks, Emma, for the introduction. She skipped over the really important part. I do have a chemical engineering degree. I graduated from Adelaide I did final year in 1983, but it's a long time since I could claim to be a practicing process engineer or a practicing chemical engineer. I kind of moved into looking at sociology and the sociology of organisations a couple of decades ago. So perhaps I'm here a little under false pretenses, and I am going to talk a bit about the engineering behind the Titan submersible implosion, but I'm also going to talk about why this happened in terms of the working engineers who were involved and some of the decisions that were made. And hopefully we can have a bit of a conversation about the implications of this for engineering ethics and engineering responsibility. So I've also got an acknowledgement of country, and I'm from RMIT University in Melbourne, and we acknowledge the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation on whose unceded lands we operate the business of the university. So I'd like to acknowledge their ancestors and elders past and present, and also acknowledge that we're on Kaurna country today. And the online people could be anywhere, so that's super interesting. Before we get started, I should also acknowledge that while I wrote the presentation, it's a group effort in many ways. We've been looking at the causation behind this incident as a group of three. My colleague, Dr. Rune Storresund, is in Berkeley, California. He's an engineer with a strong history of looking at these kinds of major disasters and the engineering causation side of things, and he's really taken a lead in what we've done on this so far. My other colleague, Professor Sarah Maslin, is another organisational sociologist, and she's at University of Canberra, and she and I have been working on this too. So, the Titan submersible implosion in 2023. Has everybody seen this in the news? Are you here because you saw it on the news and you thought, well, this sounds interesting? Yeah. Okay. So, to summarise what happened, there were 5 people on this little submersible vessel, including the company's CEO, and they were all killed when the vessel imploded due to the extreme external water pressure you get at the kinds of depths to which they were diving. So I think that's really interesting. Those of you who are, familiar with the process safety and the kind of accident causation and investigation things that we go through, so often it's a case of, senior management remote from site making decisions and then the workers die. But in this case, the company CEO was on the vessel and really suffered the consequences of the decisions that he'd made, as we're going to discuss. So in fact, OceanGate, the company that designed, built, operated the Titan submersible, and its CEO had framed themselves in the media and in their sort of public announcements as disruptive innovators. They really saw themselves as out there at the forefront of engineering doing amazing things. This was kind of the way they promoted themselves. None of this sticking with standards, none of this kind of stuff. We're out there, and we'll talk a bit more about what that means as we go through. The key design feature of something like a submersible that's diving to deep ocean depths, the biggest safety component of this is the pressure hull, and we'll talk a bit more about the design of the hull and the choices that they made, which, in line with them being disruptive innovators, are quite different to the norms in this sector. In summary, the vessel that you can see in those little pictures, the final design hadn't been subject to testing. It was not certified against current standards, and they were mindful decisions made by the CEO. Objections were raised by various people, as we're going to discuss, but they were all dismissed. So they went ahead anyway, and these were the consequences. You can see there's the Titan looking really quite amazing in the top picture, and there's the pieces on the seafloor when it was recovered sometime later. So there are 2 key foci that I'd like to have for today's presentation, and hopefully a bit of discussion we can have. The first one is sort of obvious in a sense. It's about lessons on risk management for new technologies, and in a way That's not going to be new news. There are some obvious things they didn't do. But the reason why they didn't do them is kind of more interesting, especially, you know, this is my sociology side coming out as opposed to my engineering. So the behaviours of the CEO and various others who were involved raise interesting questions about innovation, ethics and responsibility. So where does the information come from that I'm presenting to you tonight? There's basically three sources. The US Coast Guard has had a Marine Board of Inquiry to address the failure of the submarine. And the website for that, there's a substantial website for that Board of Inquiry. It includes video of the testimony of every day of the 2 weeks of the hearings. If you're interested in any of this, there's a QR code there. It also includes a really cool animation of the voyage of the MV Polar Prince, which had the Titan on it that sailed out and then was used as the platform for the Titan diving to the depth. So that's quite cool. There are also a large number of documents and transcripts on that website if you want to dive into some of the details. There is as yet no report. So the Marine Board of Inquiry hasn't reported as yet. And there's also, we've been unable to find out when they're likely to report. Maybe they're being impacted by the current political situation in the US, we're unsure, but there's no report as yet and we don't know when it's coming. So we've had to go back to first principles, and I have to thank my colleague Roon, who's watched all the videos of the 2 weeks of hearings and been through all of this in far more detail than I've had time to. Another source of information is the fact that this is in the public domain and we've got a copy. There's a civil suit, a wrongful death complaint that's been lodged by a guy called Richard Ortoli. And Richard Ortoli, let me get this right, he's the trustee of the estate of one of the people who died. And so the estate of one of the people who was killed in the incident has essentially sued OceanGate and a whole lot of other organisations and individuals seeking $50 million in damages. The suit was filed in August last year and has a lot of information in it about what happened from their perspective. It hasn't been settled as yet. They're currently arguing legal matters, the jurisdiction in which it should be heard and all that kind of good stuff that the lawyers get into. But that's quite an interesting document. It's about 50 pages. And also we've looked quite closely through the media reports, some of which is simply summarising the Marine Board of Inquiry, what's going on there. But I'm going to play you a little later in the presentation a report from a reporter who actually travelled previously on an earlier Titan trip. So as part of their publicity, the OceanGate people were getting journalists to come along on some of these trips. So it's interesting to watch a little bit of that. Okay, so moving on to the incident itself, the implosion was on the 18th of June in 2023. And the Titan was diving from this merchant vessel, the Polar Prince, down to the wreck of the Titanic. The Titan had conducted 11 previous dives since it had been constructed in 2021. So this is not the first time they had attempted this. They had dived several times and successfully to take people down to the Titanic. What happened on that day is that the last communication from the vessel itself back to the surface and the people on the support vessel was at just over 3,300 metres water depth, and the Titanic is at 3,840 metres. So they were substantially down towards the Titanic. I should say, it gives me an opportunity to mention this last communication. The way they were communicating between the 5 people in the vessel, in the submersible, and the vessel on the surface was by text message on their phones. Okay, so it gives you an idea about the kind of technology that these people were using. Anyway, so the last communication was at 3,300 metres, nothing further, and so emergency response was triggered at some point, and the debris was found 4 days later, confirming loss of the hull. The crew of 5 were confirmed to have died immediately due to the water pressure, which at that kind of depth is many, many, many megapascals, which doesn't do much for the human, skeleton and body. The people who died were Richard Stockton Rush, who was the CEO, and P.H. Nagelet, a Titanic expert who was employed by OceanGate. So 2 company people died, but they also had 3 paying customers on the vessel who'd each paid $250,000 to be out there and diving to the Titanic. And unfortunately, it was the last decision they made and perhaps not the best one ever. So Hamish Harding is a British billionaire, and the other 2 Daewoo people are a father and son who are wealthy Pakistani business people. Okay, so a little bit more about what's going on. This is a photograph that's taken from the OceanGate website, which has been taken down now, but this is their kind of like animation of what they were visualising was going to happen. So you see the tiny little Titan submarine there on the right-hand side, you know, the white object with its little headlights showing over the, you know, this is their vision of what the Titanic's like. So they're going to take people down and take them around. So in actual fact, this is a kind of gross exaggeration as to what it's like, because at those kind of water depths, the water's extremely murky. It's not like you're going to be able to see that much, etc., etc. There are all kinds of ways. This is a kind of idealised view of what they were selling. Another photo which I thought was interesting to give you a bit of an idea. This isn't the same support vessel. It's a different merchant vessel called Horizon Arctic, whereas the other one is the Polar Prince, I think. But this shows you how the Titan was launched. See, it's sitting on a kind of raft, and the Titan sitting on the raft gets sort of hauled up and down onto the back of the vessel, and then once it's floating on that raft, it moves away from the raft. So it's kind of 2-stage launch process. Okay, so let's talk a bit about the design choices that were made in building this craft. So let's start with OceanGate's corporate vision. So OceanGate is a private company that was founded in 2019, and their whole remit from the beginning, as articulated by the founders, and Stockton Rush was one of those, was to provide greater access for humanity to the deep ocean. They had this vision of people that were going to be queuing up to go down to the Titanic and to look at the ocean depths in other places. So they had this vision of creating a fleet of 4 or 5 vessels that could take people down to as far as 6,000 metres. Their vision involved not having a mothership, because these are costly to maintain and move. So they had a plan which was essentially to buy some submersible vessels and then be able to put them into a shipping container, ship them around the world, charter a support boat and operate off a support boat in various parts of the world as there was demand for their services. The alternative being the way things tend to operate with other submersible designers, where they tend to be a submersible that's attached to a vessel. And so if you want to move to another part of the world, you're sailing the vessel with the submersible as part of that to a new location. So it's a different way of providing that service, so-called almost, of taking people into the deep ocean. So that was the plan. And as part of that, they were originally wanting to purchase submersible vessels, but they actually found that there weren't any submersible vessels that were suitable for this service. No one else was doing this, and no one else was making submersibles that would work for that business plan. So the plan became design and build. So we can't do it, we still want to do it, let's design and build our own submersible, right? That's the kind of people they were, right? They're not going to take no for an answer, they're going to design and build their own. And Rush, in fact, promoted him. So this is the guy who was CEO at the time of the implosion. He promoted himself as being this kind of maverick genius or a disruptive innovator. This is the way he talked about himself. He would go to tech conferences and make inspirational speeches and frame himself and OceanGate in this way of being. There's a quote from him from 2022 where he says, if you're not breaking things, you're not innovating. He wants to operate at the edge. So let's have a bit more of a think about this idea of disruptive innovation. So This is a Harvard Business School term that he's picked up that's kind of used in business circles in the US. And the way Harvard Business School defined disruptive innovation is like this. An inexpensive product or service takes root in an existing market and then displaces established competitors by changing how consumers perceive value. So it's not just doing something and doing it cheaper, it's doing something in a completely different way that makes people think differently about that sector. So some obvious examples are, the Apple iPhone that combined various functions and displaced all the PDAs. And how, for example, another one is how Uber's changed the transport sector and also the restaurant sector. Netflix changed the entertainment sector by being the first streaming service, so changing the way that we watch entertainment. Amazon has changed the way we buy books. So these are all the kinds of companies that get framed in business school terms as being disruptive innovators. And Stockton Rush really wanted to frame his company as a disruptive innovator when it comes to subsea transportation and taking people to depths. Unfortunately, the dark underside of this disruptive innovation is that some of the companies that claim this are actually more showing the signs of deceptive innovation, which the difference being there that what they're promising vastly exceeds what they're able to deliver. And so there are some examples of that listed there on the slide as well. Perhaps one that's most relevant in that it's kind of technology-based is that Theranos finger prick blood testing. Are people familiar with that one? Yeah, some people are nodding, some people are not. Okay, so this was a woman who was a biotech promoter who effectively said that her company had created a monitoring device that meant you no longer had to do a finger prick and actually get a blood sample to do many of the common tests, that you could effectively do that just without actually producing blood. And she sold this and billions were invested in this company, but in fact the technology never existed. So she was in this sort of fake it till you make it mode. They were trying to get the technology to work, but she promoted it as if the technology already existed. And it was a couple of years in before the truth came out and all this money that people had invested turned out to be invested in something that actually didn't exist. So that's a kind of deceptive innovation. And you can see it's a bit of a slippery slope between this disruptive innovators and then people who are actually deceiving. All right? So interesting to think about that. So coming back to the submersible case, let's think a bit about the submersible design. So there are some design challenges that they faced, having made this decision that they're going to make their own vessel. So they're talking about taking it to a very extreme environment. So 3,800 metres water depth, which is where the Titanic is, and they were actually talking about maybe taking something significantly lower than that. So where the Titanic is, that's 6,000 psi, 41 megapascals or 400 atmospheres. That's a massive external pressure to have to design your pressure vessel for. The water temperature also is just above freezing, so there are some significant concerns about the safety of the crew, not only from implosion, but from freezing to death. Hypothermia is a real issue for the crews on this vessel because to go down to those depths and then come back up again takes some hours, and so they need heating or otherwise people are going to die of hypothermia. And also, as I mentioned, that earlier picture where you could kind of see the Titanic wreck, it's not like that. It's pitch dark at those kind of depths. So a very extreme environment for this vessel to be moving into, which means that there are a number of essential safety-related systems. There's the pressure hull, as we've already mentioned, but various other, life support systems related to, the breathable air and the temperature. There are also comms and navigation systems, and there are thrusters to be able to move around. So we're going to focus mainly on the pressure hull. But when it comes to these things, it's also interesting to think about, well, how is the design controlled? I'm sure many of you operate as design engineers and there are standards that you've got to follow. Ultimately, there's legislation that requires various things. And if we're talking about ship design generically, ship design is highly controlled. There are design standards from the American Bureau of Shipping and Detnorski Veritas as the main design standard agencies in shipping. There are also international shipping guidelines by IMO. There's a lot of requirements that you need to conform with if you're designing a merchant ship, for example, or an oil tanker or whatever, right? There's a lot of standards. There are also certification requirements. You know, ships have a particular home port, they're flagged from somewhere, and there'll be a legal requirement for them to obey these design standards. It's not optional. If you want to visit a port, a particular port, there are usually requirements that if your vessel's not certified, you're not coming in, right? So it's a highly controlled industry. But the regulatory situation for these submersible vessels was much, much murkier. There are design standards that exist, but in terms of the legal requirements to meet them, these submersible vessels operate in international waters, so there's no direct regulatory oversight. And the situation is much more around what are the norms of the sector rather than something where you can point to a regulation that requires people to do certain things. And that was to be critical in the decisions that OceanGate made about what they were going to do. Okay, so getting a bit more into the engineering of this thing, typical hulls for these kinds of submersible vessels are single skin, made from titanium, and they're spherical. All right, you can imagine if you're going to design something to withstand these massive external pressures, the optimum geometry is to make it a sphere, right? Okay, so that's often the case with these, and these are vessels that are used for scientific purposes. They're not usually things where people, you know, buy a ticket and go on a trip. They're for you know, marine engineers and biologists to go down there and take samples and do their thing, right? They're for scientific experiments. On the other hand, the OceanGate CEO chose to build a cylindrical vessel, and he chose to build it from carbon fibre, although there were titanium end caps. But the decision to make it out of carbon fibre was driven by the fact that that made it lighter, and so it was going to be easier to move around. You remember their business models? You know, chuck it in a sea container and send it off to another location. If you're doing that with a titanium vessel, it's massively heavy. Build it out of carbon fibre, it's easier to move. On the other hand, there may be materials people on the call or in the room who know more about this than I do, but carbon fibre, from the reading that I've been doing, is actually subject to fatigue if it goes into cyclic pressure loading. So this was a concern that was raised by a number of people, that the titanium vessels actually get stronger when they're imposed to cyclic loads, but the carbon fibre vessel, you're potentially inducing weaknesses. So the hull itself, to give you the feel for the physical dimensions, was 2.4 metres long and 1.4 metres ID, and it was 5 inches thick. So we're going to see some footage later on of people in it, but can you imagine this? So this is 5 people in that space. It's not a lot of room. You'd want to like them, you really would, I tell you. Okay, so the first version of this that they built, they then actually built a test model, and the 1/3 size hull imploded on testing. So that gave them some pretty good ideas that it was not really working too well. They made some design modifications and then went ahead. But the final design was not tested, and also the design was not certified as compliant with the relevant standards. So operating completely with no DNV or ABS certification and no test of the final design. Instead, what they had was something that the CEO was very proud of, this acoustic safety system. So apparently what happens with carbon fibre before it fails as a result of this fatigue cycling is that it kind of makes these crackling noises. And so they had this acoustic system to try and pick up if it was making crackling noises, which meant that it was about to fail. Does this sound like a really good safety system to you? Some people in the room are laughing, right? So it's telling you you're about to die, right? Nevertheless, Rush held the patent for this, And this was something that the organisation was very proud of as a safety system. I don't know what you were supposed to do. Anyway, okay, so that's something about the hull. There's a little bit about the comms as well. Titan was piloted using a Bluetooth game controller, right? Literally. And as I've already mentioned, comms between the surface and the vessel crews were via text message. And I'm just going to play you a little bit of this CBS video so you can see some of these things in action and hear the CEO talking about the design and how proud he is of various aspects of it. It's really interesting. Okay, so is it this one? No, that's WebEx. That one? Which? That one. Okay.
Catastrophic implosion. The unthinkable became all too real this past week as we learned of the fate
Oh, sorry.
explorer Stockton Rush's Titan submersible on its way to the Atlantic grave of the Titanic. The questions, the second-guessing, David Pogue tells us, are likely to continue for a long time to come.
Last summer, a company called OceanGate invited Sunday Morning to join an expedition to the Titanic. At the time, I was thrilled.
Next time I come out of this doorway, I'll either be a changed man forever or cursing the bad weather.
As the whole world knows now, OceanGate's business was taking adventure seekers on these Titanic dives
Well, we're sitting on the Titanic. We are on the Titanic.
for $250,000 a ticket on a one-of-a-kind carbon fiber submersible called the Titan.
Carbon fiber is a great material. It's better than titanium. It's better than a lot of other materials.
This is Stockton Rush, the CEO of OceanGate and the designer of the sub. Last Sunday, as he was piloting the sub to the Titanic, it imploded, killing him and his 4 passengers.
We spent 9 days at sea with Rush last summer, and in wake of the tragic news, we thought you might like to see more of what we saw and hear more of what Stockton Rush said.
The Titan wasn't like any previous deep-sea submersible. There was no dashboard, just a touchscreen computer and a single power button.
We only have one button. That's it.
Wait a minute, I've seen submersibles, and they are banks of controls, like cockpit after cockpit.
Exactly. This is to other submersibles what the iPhone was to the BlackBerry.
But many of its components seemed surprisingly cheap. For views outside the sub, he had installed store-bought security cameras. As for the ceiling lights,
I got these from Camper World.
and then there was the steering unit.
We run the whole thing with this game controller.
Come on! So, it seems like a lot of the way you made this is by taking off-the-shelf parts and sort of MacGyvering them together.
Yeah, pretty much.
Does that not raise anybody's eyebrows in the industry?
Oh, yeah. Oh, yeah. Yeah, no, I'm definitely an outlier. There were a lot of rules out there that didn't make engineering sense to me.
Everyone I know keeps asking me the same question. Why would you get on that dangerous sub? Well, first of all, Stockton Rush had the credentials.
He majored in aerospace engineering at Princeton. He designed and flew his own airplanes. He designed previous submersibles. Second, he was emphatic that the important parts of the Titan were rock solid, like the carbon fiber body for which NASA served as a consultant.
There's certain things that you want to be buttoned down, and that's the pressure vessel. Once the pressure vessel is, you're certain it's not going to collapse on everybody, everything else can fail. Your thrusters can go, your lights can go, you're still going to be safe.
Third, I was convinced by an expert, P.H. Nargeolet, the veteran deep-sea explorer who also perished in the Titan. Over the years, he'd been to the Titanic more than just about anyone.
How many times have you been?
With the last dive, 37 times.
You've been to the Titanic 37 times?
Yes. I was in charge of 1, 2, 3, 4, 5 subs.
How different is the Titan from those other subs?
Completely different. Most of them, you have a sphere.
Was there never a point when you wondered about the safety of the sub at that depth?
No. 2 or 3 years ago, I had a phone call with Stockton, and he explained to me that he was doing a lot of tests. He showed me the ways they were building the stuff. I said, okay, that's fine. That's fine. I have no problem to dive in the sub.
I was also impressed by the sub's 7 redundant systems for returning to the surface.
These are roll weights. We can actually roll this up and those come off. That gains us some buoyancy to come back to the surface. Okay. These triple weights, we call them, are hydraulically driven.
Expedition manager Kyle Bingham.
Underneath this tray hang these bags, around 35 pounds. And those hang down there. Typical dive will have 8 of them. We can also use our thrusters. We have enough power to thrust back up. And then under this last fairing here, we have our variable ballast tank, or soft ballast. It's an air bladder that we use a big 10,000 PSI air tank that's under the tail to fill that up, fill it with air, and then it helps bring us to the surface.
There were even sandbags that detach automatically after about 16 hours, even if everyone inside had passed out. Their connectors would dissolve in seawater.
So you have a backup of a backup of a backup of a backup of a backup.
Correct.
All stations are reporting the dive to go. Please stand by.
Finally, the crew seemed to foster a culture of safety. There were checklists, inspections before and after every dive, and a 3 strikes rule. If 3 things seemed out of the ordinary, no matter how minor, they'd cancel the dive. I learned that the hard way on our own dive.
We're in the water, we're floating.
Woo! At this point, divers are supposed to detach the sub from its launch platform.
So apparently those floats there came off the platform, and that wasn't supposed to happen.
So we're scrubbing?
Yeah, I think that's the consensus up here.
Copy that.
I never did see the Titanic, and I wasn't unusual. In OceanGate's first 2 summers of Titanic operations, it spent a total of 50 days floating above the shipwreck site. But because of waves, bad weather, and malfunctions, the Titan actually made it to the Titanic only 12 times. But through it all, Stockton Rush defended his unconventional approach.
I mean, anything when you're trying something outside the box, people inside the box think you're nuts. Same thing when Elon Musk was doing SpaceX. Inside the box, everything's scary.
But as early as 2018, there was concern about the Titan's design. A former employee says that when he raised safety concerns, Rush fired him. That same year, a group of submersible engineers urged Rush to seek certification of the Titan by a safety agency. Rush declined, saying that regulation would stifle innovation.
At some point, safety just is pure waste. I mean, if you just want to be safe, don't get out of bed, don't get in your car, don't do anything. Yeah. At some point, you're going to take some risk, and it really is a risk-reward question. I said, I think I can do this just as safely by breaking the rules.
So,
So I'm going to stop it at that point, because I thought that last thing that he said about you've got to find some point at which you stop for safety is really interesting and true, but the point at which he chose to stop is perhaps not where we would choose to stop. Okay, so when we get to questions, I'd be really interested to hear your thoughts on some of those other things that he said. But for now, I'm going to tell you a little bit more about what was going on regarding the safety aspects of the decision making, and they alluded to some of these things in the video. So there were multiple people that expressed to Stockton Rush that there were significant problems with what was going on. So some of these people were senior employees of OceanGate. Some of them were contractors that they'd used who then continued to work and do further modelling that they were not paid for in an attempt to get OceanGate to change their mind. And the problems that people raised with him are listed there on the screen. So people raised the issue of using carbon fibre in this application at all. Was that suitable? There were others who raised manufacturing concerns about some aspects of the way that the carbon fibre shell itself was manufactured, and then linked to that was the lack of quality control, which then would fail to reveal the manufacturing problems themselves. So those related issues. Another point that was raised by one of the operations people, not the guy we saw in the film, but somebody else, was that the fact that they had been popping sounds heard on previous missions, and you might remember me saying that this sound, this acoustic thing, is an indication perhaps that the carbon fiber's got a problem, but there was no operational NDT done following any of these as a result of these sounds. Various other people complained there was not enough time for adequate operational safety assessments, partly related to this popping sounds feedback thing, but a bunch of other things that were happening on missions. Various people were also concerned about the composite nature of the design of the vessel itself. So you had this carbon fibre cylindrical aspect of it with the titanium end pieces, but there was also a window cut into the side of the vessel, and there were concerns raised about the stress concentration associated with putting a window in the side of it. And also, obviously, some people were concerned about the lack of certification. And as one person said, it's not about being a disruptor. This is about the laws of physics. It's just not going to work. But despite this, Rush ignored those comments. This is the letter that was alluded to in the film. So a bunch of people from the Industry Association, the Marine Technology Society, wrote to him expressing their concerns. And it's there because I think the whole thing is kind of interesting. But to summarise, for those who are not feeling in the mood to try and read through this, the letter is sent on behalf of the members of this society, effectively saying, we're all in this together. We have a good reputation as an industry because we take safety seriously, and you're in danger of wrecking that for all of us because you are not taking this seriously. And they were also pointing out things like his marketing material for OceanGate says that the Titan design is going to meet or exceed the DNVGL safety standards, and yet it's not certified against those standards. So he's implying that it has been certified when it hasn't. So, yeah, they are effectively urging him. So the second to last paragraph, they're urging him to agree to doing performance-based testing on the vessel before it's launched. But again, he ignored this. One of the former employees of OceanGate, a guy called David Lockridge, who was Director of Marine Operations, put his concerns in writing after raising them on numerous occasions, and he was actually dismissed in 2018. This is something that that was also mentioned in the CBS film. Not content with that, this fellow made a whistleblower filing to the US Occupational Safety and Health Agency. So there's a program for OSHA in which people that work for companies who are concerned about safety matters can actually make a complaint directly to the agency and encourage the agency to investigate. OceanGate's response to that, when they found out that a complaint had been lodged with OSHA, is that they did this, what's possible in America, they then filed a SLAP suit. And a SLAP suit is a strategic lawsuit against public participation. So what happens in the US on occasions, this is a kind of well-known strategy, if somebody files a complaint against you under whistleblower legislation, you then effectively sue them against this other legislation, which then means that they become so concerned with managing their own legal risk that the idea is that they will then withdraw the whistleblower complaint. Okay, so it's a response to whistleblower legislation that's kind of grown up as a legal practice in the US. Now, OSHA tried to support Mr. Lockridge through this on his employment issues and on the fact that he'd had this SLAP suit against him. There are lawyers within OSHA who were very familiar with this because it's a common strategy. So OSHA were in some ways very sympathetic towards David Lockridge, but they never actually investigated his safety concerns, which was the whole reason he approached them in the first place. So an absolutely lost opportunity there. So what we see in summary is that major concerns were raised by senior staff, by consultants, by professional peers, but OceanGate's response was either to file lawsuits against them or to threaten to file lawsuits against them. So they were using these legal methods to try to restrict what people were saying. So that, in other words, the concerns that were expressed were not acted upon, but they were effectively silenced by legal means. Further than that, the company implied publicly that NASA, Boeing and the University of Washington were co-developers and or co-manufacturers in this process. You might have heard that the CBS reporter mentioned that NASA was involved. So it is true that NASA, Boeing and the University of Washington all did small pieces of paid consulting work for OceanGate, but none of them certified the design. And in fact, NASA recommended that the wall thickness of the vessel, if they were going to make it out of carbon fibre, needed to be 10 inches and not 5. So statements made implying that these companies actually approved of what was happening were exaggeration at the best. And also he said publicly that the vessel would meet DNV requirements, and that kind of that language implies that it's going to be certified, but it never was, and it certainly didn't meet those requirements. So you think, what was going on here? Well, nearly to the end, and I'd be interested to hear some of your thoughts about what we can learn from this. So there is a psychological phenomenon called confident ignorance, and this is a psychological state in which an individual displays a high degree of confidence about what they know, despite lacking sufficient or accurate understanding of the subject, and critically, they maintain confidence in their opinions despite contrary evidence. So some of you, I'm sure, are familiar with the Dunning-Kruger effect, which says that people that don't know they don't know. This is a step further than that. This is, we don't know, and even when you're presented with enormous evidence to the contrary, you still become fixated on your view and you will not change your mind. And so, you know, to link it back to other more safety-related theories, Rush himself was completely lacking in a safety imagination, i.e. his ability to link day-to-day actions to the potential for catastrophe. I mean, he was on the vessel himself. What more evidence can we have that he just didn't understand how risky this was? So that's some kind of interesting things about him and senior management decision making and some of the things that can go drastically wrong. I think it's also interesting to think about this in relation to engineering responsibility and all these engineers who tried to stop him in various ways. Now, they were unsuccessful. You know, engineers don't have infinite amounts of power. The guy with a checkbook perhaps ultimately prevails. But there's a really interesting literature around engineering responsibilities that I'd be interested to hear your thoughts about. So first of all, there are two different kinds of engineering responsibility that we might want to think about. Backward-looking responsibility is about saying you should have. Okay, it's about blaming people after something goes wrong. You should have done this, you should have done that. And that's the way in which we kind of sometimes think about engineering responsibility in terms of liability and blame. But to prevent accidents, actually much more important than that is a forward-looking orientation towards responsibility. And this is thinking, what should I do to prevent something going wrong in the future? What can I do to make sure things go right? Rather than, how do I protect my liability so if things go wrong, I'm not going to be blamed for it? So hopefully we can all take a more forward-looking approach to thinking about our engineering responsibility. And then if we think about, there is a literature also about how you balance engineering and management responsibilities, with engineering sometimes at an extreme being cast as gold plating and management being tasked as, you know, we want to do everything as cheaply as possible. How do you find that middle ground? And the answer that we have in this country, as in many others, is to find this appropriate balance between cost and safety by application of principles around this reasonably practicable idea. And I could have talked for 45 minutes on reasonably practicable, but I'm not going to. So this is where you have to think about things in those terms, because cost is a legitimate consideration, but clearly we don't want to kill people. So we need to find that balance. And there are other famous accident cases where this balance was not achieved, and, you know, I can come back next year and talk about one of these if you're interested. Boeing and the choices they made around the 737 MAX disasters, where engineers knew there were problems and some of the engineers effectively colluded with management and kind of swept the issues away in the interest of pushing forward and getting those 737 MAX planes out there, and others were very concerned and tried to stop what was going on. So that was going on inside Boeing. And the other famous example of this is the Challenger space shuttle, where you had these solid rocket booster seals, which eventually failed and led to the loss of the shuttle. And there was a long history over years of the decision-making around that, a known design problem that was never addressed. So we heard Stockton Rush say this in the video. At some point, safety is just pure waste. But it behoves all of us to think about, well, what is that point, right? There isn't an infinite amount of money to spend, but we need to take it seriously and acknowledge that this point exists, but make sure we're not operating beyond it. So then, okay, what should any individual engineer do? Here are some suggestions that come from our research. First of all, foster your safety imagination by building up a mental store of failure cases from your industry and others. And that really helps you make the day-to-day link between the banal thing that you have to do on a Wednesday afternoon and I need to do this properly and take it seriously because if I get it wrong, someone could die. On the other hand, engineering is a very social occupation, so there'll be things that you're doing where you're part of a much bigger group of people, and you might see something coming up that's making you uncomfortable, something that you think should be done done differently, etc. So we would suggest the second dot point up there, speak up early and make a case for change when you believe it's necessary. So don't wait till the last minute. The boss is going to be legitimately annoyed with you if you've known about this for some months and kind of not mentioned it, and then at the end you go, okay, actually, I can't sign this drawing because I'm really uncomfortable. And that's the first they hear about it, right? You should be talking about these things earlier. The other important point that's come out of some of the research we've done is about how you make a case to senior management that something needs to be done differently. And there's a lot of evidence that going beyond engineering jargon in making your case is very helpful. So we've had engineers talk to us about the fact that they put forward the engineering information and they effectively say, well, that's it, job done. But in fact, if you know that the group of people you're talking to are more management and commercial types, then it behoves you as a professional engineer to be able to communicate to other disciplines and other professions. Something else you can do is the social nature of engineering means that you're often not alone and you can often enrol others to support your conclusions. If you're worried about something, talk to the discipline lead if that's the case, talk to the operations people, talk to others to kind of benchmark your thoughts about whether your concerns are valid and enrol others to support your conclusions. Putting logic in writing is a good practice for a whole range of reasons. And I guess lastly, accepting that you have responsibility, but there are limits to it. At the end of the day, David Lockridge didn't stop Stockton Rush from going ahead with the Titan. So here are some things. I guess I can't come to an engineering thing and focus entirely on the kind of social sides of things. We do need to have a bit of a look at what are some of the lessons for new technology, although I think this is kind of less interesting in a way and perhaps more obvious. So the whole confident ignorance piece I think is interesting. People can be overconfident and sometimes you can't convince people. So the only way to get around that is checks on power effectively and having multiple decision makers involved. Less dramatically, losing sight of the consequences can be something that happens in the face of the desire to be the forefront of the field, this innovative organisation. An obvious one, pay attention to bad news as a source of valuable information. When we talk about that in organisations that are much larger than OceanGate, by talking about making sure that organisational structures are such that bad news can travel upwards and that senior managers can hear about things that are going wrong rather than making decisions in ignorance. And from a process safety perspective, of course, inherent safety in design is critical and they completely overlooked that. And they also moved into operations without testing, and we see that happening in some of the accident literature as well. So that's about enough from me at this stage of the evening. Thank you very much for your attention, and I'll be interested to hear what you think. Ooh. Yep, sorry.
They're going to do a Q&A.
Yep.
So what we'll do here will be roving mic. Can you use hand mic, please? That mic's too quiet.
Yep. Sure. Yep, it's on. All right. What questions have we got online?
So if anyone has any questions in here, raise your hand. We'll come with a mic just so online can hear what you're going to say. And just say in the mic that we'll do Q&A.
All right, so we're starting Q&A. We're all set up in the room now. So we're just getting used to the technology. We've got quite a few coming through. All right. Do we know what was the failure mode, the cause of the popping sounds?
No, I'm not a materials engineer, and I'm sure that information is available on the Marine Inquiry website somewhere in the details, but that's not something I'm across, I'm sorry.
Was OceanGate in any financial difficulty at the time?
No, it was a private organisation, but they seem to have lots of money to play with, right? So they were not under, often these tales are pressures from shareholders and things like that. But this was a privately owned company, and Stockton Rush was one of the owners. So no, it was kind of their plaything. Shanti, perhaps Shanti's got a question in relation to that.
Oh, I've got a roving mic.
So we're talking about a lot of this stuff like that happened in America, and it's very easy to sort of think, oh, America, they're a bit like that. And it's one of the things that sort of made me think was when they talked about that whistleblower one and then the slap response. And we've definitely seen in Australia about whistleblowers being prosecuted. Yes. I think most of the examples have been like government, but there's 2 cases I can think of quite prominent where whistleblowers are still dealing with issues and potentially going to jail for that. So in terms of this has happened in America, do we actually think somebody in Australia could get away with this? Do we think we've got better protections in Australia?
I don't know enough about the submarine sector to know whether that would be possible. But generically speaking, if you had a new industry that was not heavily regulated, many of the same things could happen here, because this was so much down to the personalities of the people who were involved, because it fell outside of all the governance structures that we rely on. So yeah, I mean, I think it's quite credible that there are lessons we can learn from this, and that to dismiss it as it happened in America, so we've got nothing to learn, I think is a bit short-sighted. Thanks for that.
All right, we've got heaps coming through online.
Okay.
I'll have to pick a few and then we'll call it for the day, but we've got a few more. So you mentioned in your presentation that OceanGate had successfully launched submarines in the past. Could you clarify how those designs were developed and whether they were officially approved and certified by any regulatory bodies?
They were not certified and approved. None of the designs had been. I can't tell you a lot of the details. It was very much an R&D kind of environment when they very quickly pivoted from we're going to buy submarines to we're going to make our own, right? So it was very much an R&D kind of environment. Yeah.
Sounds very cowboy to me. That's the impression I'm getting.
So some of it, when I mentioned the manufacturing problems that some people were concerned about, Titan was manufactured from a batch of carbon fibre that OceanGate bought from Boeing that was beyond its use-by date. And Boeing wouldn't use it in their aviation applications because it was beyond the use-by date, but OceanGate bought it and used it. So this is the thing, when they say that Boeing's been involved, yeah, Boeing has been involved, but not in a way that effectively implies that they agreed with the decisions that were being made.
Okay. Oh, I skipped one. Is there any government organisation that could stop what he was doing?
No, because it was happening in international waters. So there was really no regulatory oversight of this. I mean, this is why David Lockridge made his complaint to OSHA, because you could potentially argue that he was endangering the life of the crew even back. But even then, it's dodgy because it's in international waters. It was quite difficult.
That's not going to have changed.
No, that's not going to have changed.
All right.
It's the fact that the vessel's got no home port, and so no one's responsible.
Coming in so quickly, I keep losing my spot.
So while you're looking, maybe I can mention one thing. I thought it was super interesting in the CBS video where you've got the operations guy pointing out I think it was something like 6 redundant systems for the risk of the vessel not being able to be recovered, right? So they've clearly done some kind of risk-related thinking and come up with the fact that the most dangerous thing that can happen credibly is that the vessel is down on the ocean floor and they can't recover the people. So then they've got something like 6 different systems to change the buoyancy arrangement so that it comes back to the surface. So they were not ignorant of risk-related things, and they were doing some things from a safety perspective. So they kind of went down this track of having multiple systems for one hazard, but then they missed completely that they've made these design choices about the integrity of the vessel itself that are just giving them a super high risk in that space. I think that's super interesting thinking.
That does actually answer one of the questions online as well. So
Okay,
did they perform any risk analysis? So they did some, but it doesn't seem to have been as structured as what some of us would be more familiar with.
Right. They also were big on operational risk analysis. So you saw them all with their checklists and things in the news footage. There are documents on the Marine Inquiry website which are labelled as operational risk assessments, and they were worried about, people being hurt during the launch of the vessel, all those normal kind of workplace health and safety things that you might think of working in this kind of hazardous environment, but there was nothing about the integrity of the actual hull.
Got one in the room?
You mentioned the cyclical stress was meant to put stress on the carbon fibre over time. Do you know if they did any kind of analysis in between, trips to see if they were degrading the hull or anything like that over time, or was it just assumed that it was maintaining a steady state?
It was assumed it was maintaining a steady state, is my understanding. They did a visual inspection, and that's all. Yeah, that's my understanding. It's possible you might find buried in the Marine Inquiry someone who did some study, but I haven't found it. Yeah.
Just jumping off that comment, is there any documentation about the planned life cycle of the vessel? Like, did they plan to retire it after a certain amount of dives?
I don't know, but that's not really the way they were thinking, was it? Yeah. Sorry, I don't know for sure.
All right, we'll go for one last one online because it's 7 o'clock and we've hit the end of the session. So Tim has asked, what is the state of the investigation and legal cases against OceanGate, and what is the legal status of the 1,000+ page waiver document that the passengers needed to sign?
Okay. So, yes, what Tim was alluding to that I didn't mention was that the passengers to get on this vessel had to sign a waiver that acknowledged that they might die, effectively. I'm not sure that anybody has challenged that directly, but it will certainly be addressed as part of the wrongful death claim that I mentioned. It's described in detail in that wrongful death claim, and the lawyers are putting an argument that says that it's not valid and that the passengers didn't have enough information and were in fact misled by OceanGate regarding various risk-related matters, and so they were effectively signing it without proper information, so it's not valid. I don't think anybody has made a determination on that because, as I mentioned with the wrongful death claim, they're still arguing the legalities of, you know, in what jurisdiction it should be heard and whether there's jury and all that stuff. So, yeah.
Sounds like it'll go on for a long
Yeah, I think so.
So there's still quite a few questions, so we might see if we can email them through to you and see if there's any extra interesting ones that need answering that can be shared with the attendees.
Well, so thanks for the questions about the case itself, but hopefully those slides towards the end about your responsibility as professional engineers and things like that will give you some food for thought as well.
So thank you once again for a very fascinating talk. As you can tell by the number of questions that everyone's had, that everyone's enjoyed